So what's really, really fun about working in Near right now is that everything we're building here is not just for Near anymore. It's actually for every single chain, and as Ilya pointed out, it actually goes even beyond Web3 in general, and we're going to be able to connect to really anything on the internet, and hopefully actually change a bit about how the internet works. But today we'll focus on what we're going to be able to bring to all these different chains that are out there and why we're super excited about it. And I think when it comes to really making AI agents work in crypto and solving a lot of the problems that we currently have, what's going to be really required is that each AI agent has unfettered access to the entirety of the crypto space. This includes every single crypto asset, this includes every single smart contract, and really every single piece of state. This is part of the reason that we've been so focused on this concept of chain abstraction. It really is to make it so that developers and users are able to interact with every piece of state, every asset, everything on every single chain as seamlessly as possible. The way that we're making this work is using the Near abstraction stack. So Alex just introduced a really important part of that stack, which is the intent layer. We also have two other really key pieces of technology. One is chain signatures, and the other is the Omni Bridge. So to give you an example of how this can kind of work, you can imagine that a user first creates an intent, basically submits a request to this intent and solver network. Once the auction is kind of decided, once like a solver is sort of chosen either by the user or through a programmatic way, that fulfilled request will then turn into a signed payload that can be relayed to a destination chain. And that's using chain signatures. And then once that's complete, let's say that there was a Bitcoin transaction that landed, oftentimes there's going to need to be a settlement process that happens on the Near side. And this is where Near as a blockchain will need to have access to that finalized state transition on the Bitcoin blockchain. And this is going to be using the Omni Bridge, which is effectively a wrapper over some different message passing layers or even light clients, depending on the chain, that will let the Near smart contract know that that state transition on a destination chain has finally landed. So the most important takeaway from the piece of technology that I'll focus the most on today, which is chain signatures, is that we now have enabled smart contracts to sign transactions. And this is a really, really interesting design space that we're seeing a lot of teams start to take advantage of. So here's a little bit about how it works. So you can imagine on the one side, we've got this Near account that's on the Near blockchain that will be originating some type of signature request. So it'll call right now this signer contract on the Near blockchain with a payload, a cryptographic payload to be signed, and then basically the address that it wants to use to sign that transaction. Then the real magic we have here is this network of multi-party computation nodes. You can basically imagine these as a large group of distributed entities that have one part of like a key share that can be combined to sign for a private key that none of these individual parties know. And the goal is to make this group as large as possible, eventually hopefully resembling the makeup of the Near validator set. So this group will listen to requests that come in on that signer contract, and they will then take that request and sign it using a deterministic derivation function that will basically ensure that this Near account is the only one who can originate and sign for this request. They'll then return that signature on the Near blockchain, which creates a perfect audit log of request and then response, so you can verify that this was done correctly. And then finally, that transaction will be passed to a destination chain. And this is how you enable Near smart contracts to sign transactions for Bitcoin and Dogecoin and Ton, Solana, any chain that comes up with, any of the thousands of chains that apparently are going to be launching over the next few years, you'll be able to use this technology. Right now, we have about 24 teams who are building across 3 major categories. The first one, and one I find particularly exciting, is Bitcoin. In 2024, we've really seen, I think, a resurgence of, a realization that Bitcoin is kind of the OG of crypto assets. For a variety of reasons, it's going to be extremely important to continue to utilize. But to date, it's actually been pretty difficult to build with Bitcoin in kind of a trust-minimized way. Fortunately, using chain signatures, we're able to enable teams to tackle some really exciting use cases. On the one side, we've got Bitcoin lending. It's surprisingly difficult if you have Bitcoin on the L1 to borrow against your Bitcoin. Step 1 is usually some type of bridge that has quite a bit of latency. We're going to be able to really remove this using chain signatures. Part 2, runes trading. You've probably heard a lot about this as a primitive. People are very excited about the ability to issue assets on Bitcoin. But to date, that experience has been very limited when it comes to actually trading these assets because the Bitcoin layer 1 itself is limited. And then we, of course, have several other use cases here, like restaking or building liquid stake tokens on top of these restaking platforms. And we have several teams who are tackling that challenge. To give you a little bit of an example of what this can look like from an experience perspective, this is actually a fork on testnet of the largest lending protocol on Near that's empowering this Bitcoin experience. So you can see here I've actually connected my Bitcoin account using Unisat to this lending protocol. And you can actually see like a testnet Bitcoin balance right there. I can then actually just decide to borrow against this Bitcoin balance after I've deposited into the protocol. You see here, I'm going to like supply a little bit of Bitcoin. And then this transaction request that pops up is actually from my Unisat wallet. Because thanks to this chain signature technology, we are able to let users bring their existing wallet, any Bitcoin wallet that they have their Bitcoin custodied in, and then they're able to basically interact with this protocol just by signing a message using that wallet. And this same pattern can be replicated across anything. So Bitcoin users are able to be met where they are in their Bitcoin wallet, but then get exposure to all of these different usage patterns and all of these different new experiences. The next category we have a lot of teams building in is, I think, particularly interesting because it really changes the way that you can reason about like how you're designing your protocol. And what we mean by that is you no longer have to think in terms of how you're going to deploy your protocol on one chain, then you deploy that same protocol on another chain, and then think about how maybe there's two different versions of your protocol interact with each other. You can actually design your protocol to be completely agnostic to the eventual chains that your users will be interacting with. To give some examples of how teams are using this, Alex already showed an example of the near intents layer, which is basically making it so that you can swap any asset between any chain. We have a couple of other teams who are working on similar products, like Omni and Thesis, who's building a margin-based spot protocol that will actually allow users to deposit any asset and leverage against it. We have teams building lending protocols, particularly targeting very popular but underutilized assets like an XRP or a Dogecoin or even a Bitcoin. And eventually, you will even be able to borrow against your entire portfolio of assets that might span across multiple chains and opening up an entirely new capital base. And then we, of course, have teams building in like the yield space, the restaking space that will allow you to restake any cryptographic asset across any chain. To show a little bit about how this could work, very similar to the example that Alex gave earlier, this is a team called Omni who's built cross-chain swaps that will enable you to swap between any two assets on any chain. You can see here I basically connected my MetaMask account, and then I'm just going to go through and swap from the Polygon testnet over to Base. And it works pretty similarly to the intents layer, where you'll basically find a solver who will fulfill this for you in just a matter of seconds. And this experience will be replicable across a variety of chains. And then last but not least, we have account abstraction. We have a lot of very exciting teams building in this space, particularly Bitsa on like the kind of AI agent-powered end user experience. We have one of the most used apps in crypto, if you're familiar with the Hot Wallet, which is built in Telegram. They've actually deployed 6 million chain signatures-powered wallets that can actually like custody assets across a variety of chains. And then we have teams like Sweat, who is one of the largest kind of mass market user apps and is now able to bring their 100 million user plus base across a variety of different blockchains and applications. And then tomorrow, you guys will be getting a very special announcement from a very exciting team who's building in this space as well. I think what's super exciting about like what Bitsa has been able to do is that they can take a new design pattern, like a passkey-based wallet, and they can let you create a unified balance across a variety of different chains. So like you can see here that I'm actually have some Ethereum on a few different chains in my Bitsa wallet. And I can actually go and I can just connect my Bitsa wallet to Uniswap or any other application that supports Wallet Connect, and I can suddenly send transactions from that application. So you can see here I'm actually like sending this Uniswap swap, approving it on the Bitsa side. I'll actually sign using my passkey on my Mac, and then I've completed this transaction. You can see I now swapped from some Ethereum on Base to some USDC on a different chain. And of course, you can do this through the AI agent platform as well. So those are three of the areas we see a lot of teams building in. I think a really cool direction that we're going to be able to go that's uniquely unlocked by this MPC technology is actually building truly unstoppable autonomous AI agents. So we had Alex Goodenough mention earlier how you're going to be able to basically receive a verified request from an LLM by using a trusted execution environment. That's a really exciting primitive that lets you interact with an AI model and know that you were served from the AI model you're aiming to interact with. But I think what's even more interesting is when you combine this with the key resiliency of the multi-party computation technology, you can actually have these agents that'll just live as long as the network lives. Everyone's really excited about the idea of, well, effectively enabling like a Skynet, but no one's really put together the pieces to actually empower this today. So like we see a lot of hype on Twitter right now about what is going to be able to be unlocked with these primitives, and I'm excited that we're actually going to be able to deliver this tech stack immediately. So you can imagine that you basically have that AI agent that will be have most of its sort of information and state either living on the near blockchain or a variety of decentralized technologies. A user will then be able to prompt this agent. You'll see like a trusted execution environment where someone's running this model that'll basically return the response and then the proof of the response using the remote attestation. And then this response will be able to interact with the nearest smart contract to then sign something somewhere. And because this smart contract will be using this distributed MPC technology, what that means is that in order to take this agent offline, you have to take down the entirety of the network, which is going to be extremely difficult to do. So this is how we can unlock these kind of truly perpetual and autonomous AI agents, which we're very excited to see how people build with this.